All right, let's talk about perimeter and area of similar polygons. So if two polygons are similar, which remember that means same shape but a different size, all right, then the ratio of any two pairs of corresponding side lengths are equal. So let's not forget, we don't want to be as scared of this word ratio. A ratio is a reduced fraction or a simplified fraction, okay? So don't freak out about the word ratio. A ratio can be written as 2 to 3 with a semicolon. It can be written as a fraction, 2 to 3, or you can write it as 2 to 3. So these are all different ways to write a ratio. All right, so a ratio is just a simplified fraction that is used to compare sizes of similar figures. A ratio may not be the actual measurements. For example, if this is 4 units and this is 6 units, right, this is the actual measurements, but if I were to want to make a ratio, I would have to reduce these given side lengths. And you see, this is an actual ratio. It is how it is used to describe how the figures are related in size. A ratio represents the simplest, okay, form of geometric measurements. So again, you set up a fraction of the corresponding measurements given, you reduce it, and that is your ratio. So do not be afraid. Just reduce to get a ratio. Reduce, ratio, R to R. Okay, so if two polygons are similar, the ratio of their perimeters will actually be the exact same ratio, so will be equal to the ratio of the corresponding side lengths. So if these two figures had a ratio of side lengths from 2 to 3, their perimeters, if we were able to find them, would also be in a ratio of 2 to 3. Now area, so if two polygons are similar with the lengths of corresponding sides, or this could be corresponding perimeters. So if you have any ratio, and this is like A to B, so it could be 2 to 3, 3 to 5, 9 to 25, whatever the ratio may be, then the ratio of the areas is whatever that ratio is, but you square the numbers. Okay, so ratio of the areas can be found by squaring, raising to the second power, the ratio of the lengths or perimeter. So this kind of shows you, and again, if we were to use that first one as an example, it had a ratio of 2 to 3, then that would mean if we were to find the actual areas and reduce them, that we would get 4 to 9, because if we square 2, we get 4. If we square 3, we get 9. So now number 1, find the ratio of the perimeters. So let's first do that. So again, perimeter and side length, they kind of go hand in hand. So I'm going to first say, okay, this 2 corresponds to this one. So remember, it's all about corresponding measurements. So 2 over 2t, these correspond. Well, if I want to find the ratio of these corresponding measurements, I have to reduce this. All right, so you have to reduce, take a 2 out of both. This is what that reduces to. So this is the ratio of the perimeters. Okay, now if I want to find the ratio of the areas, I have to take whatever this is and I have to square it. So if I do 1 squared, I get 1, and if I t squared, I get t squared. So this is actually the ratio of the areas. All right, and you are done. Now, if you want me to prove that to you, I can prove that to you because we actually can find the areas over here. So if I found the area of this rectangle, I get 6. If I found the area of this, I get 6t squared. So these are similar and correspond. If I were to reduce it, this is a ratio, and you see how the ratio is equal to the ratio. Magic. All right, so number 2, in the diagram, triangle ABC is similar to triangle DEF. Find the ratio of red to blue of the perimeters. Well, perimeter and side length, all right, they're the exact same ratio. So find corresponding. So BC, we know BC corresponds with EF. So these are my corresponding measurements. To find a ratio, I'm going to reduce. Ratio reduce. So take a 4 out of both. There's my ratio of the perimeters and the side lengths. What if I wanted to know the ratio of the areas? Can we find the actual areas? No. But if we were able to, and we reduced it, we would know, right? Area. Think about area. Area is always inches squared, centimeters squared. So you have to square 2. You have to square 3. And that's going to give you your ratio of the areas. So 4 to 9 would be the ratio of the areas. All right, so let's move along to the table. So side length and perimeter, they always contain the same exact ratio. Remember, area is always units squared. This becomes two-dimensional. Square 2, you get 4. Square 3, you get 9. Right? Perimeter and side length, same ratio. Perimeter, side length to area, you square. So 3 squared is 9, 5 squared is 25. Oh, now look, we're starting with area. So to go kind of backwards, if you will say, to go back to just side length, you have to square root. So the square root of 36 is 6, right? The square root of 25 is 5. So we have found the ratio of the perimeters and the side length. So very easy, just square root that. Okay, number 4, it's telling you they're similar. Find the ratio of shaded to unshaded of the perimeters and the areas. Well, look, they're giving us corresponding side lengths. So if I say, okay, these guys correspond. Now if I reduce that, and again, these are just side lengths, so this is my ratio of my perimeters, okay? If I wanted to find the ratio of the areas, I would have to square this. So 1 squared is 1, 4 squared is 16. So 1 out of 16, this is my ratio of the areas. Now the last part says find the unknown area. So this is where you're going to spend most of your time. Similar figures, remember, they have corresponding measurements that are proportionate. So I bring up that word proportionate because that's how you're going to solve for unknown area and perimeter. The main thing you've got to remember is that if we are looking for area, all of this has to represent area, aka represent a measurement that has been squared. So I'm not going to use this in my proportion if I'm trying to find area. I'm going to use this one because area and area. So 1 out of 16. Now, does it matter if it's 1 over 16 or 16 over 1? Nope. Okay, what matters is they're giving you an area right here of 3 feet, which is squared, which is obviously the smaller figure. So that 3 feet has to go on the numerator with the smaller number in the ratio. We don't know what this is. Now we're going to cross multiply, and voila, we can solve that that bigger figure has an area of 48 feet squared. Same thing over here, okay? 9 to 15, okay, those correspond. Now I'm going to reduce, take a 3 out of both. Okay, this is the ratio of the perimeters. I'm looking for area though, so when I come to do this proportion, I have to make sure I square this ratio, right? So 3 squared is 9, 5 squared is 25. Does it matter 9 over 25, 25 over 9? No. What matters is this. 225 inches squared is the larger polygon, so it has to go on the numerator with the larger number, okay, in your ratio. Now we're going to cross multiply. You should have installed, if you don't have a calculator, remember I gave you this link to download this onto your desktop, so you hopefully either have a calculator or have been using it. So we get 2025 and we're going to divide that by 25, and lo and behold we get 81. So our smaller figure has an area of 81 inches squared. Bam. Let's go on. 5. These are ratios of areas. They want to know what the ratio of the side lengths is. Well, just square root it. Square root of 9 is 3. Square root of 25 is 5. You're done. Call it a day. Square root. Okay, square root of 36 is 6. Square root of 4 is 2. Now, what you need to be careful of is this is still not all the way reduced. When you give a final answer, you need to make sure it is in the simplest form. So we're going to reduce this even further and 3 to 1. Now you can reduce at the beginning or the end, it doesn't matter. Okay, 6, the ratio of the side lengths is 5 to 8. What is the ratio of the areas? Square that stuff. 5 squared is 25, 8 squared is 64. Bam. 7, the ratio of the areas is 16 to 9. What is the ratio of the corresponding sides? Well, I'm going to square root that. Square root of 16 is 4, square root of 9 is 3. Is that it? That's it. Okay, last one. Use the given area to find x, y. So on the grand scale of easy, medium, hard, these are on the harder side. The hardest we're going to do. Okay, so we have to find x, y. So x, y is going to correspond with hj. So hj corresponds with x, y. But we're given area. So area and side length, they kind of don't mesh, okay? Do they have something in common? Yes, okay, but we're just going to use this. So 168, so these are corresponding areas, okay? You have to reduce this, folks. So please use your calculator to reduce this. 168 divided by 378. And this is why we need a fraction. So there, this reduces to 4/9. Now we're trying to find a side length, okay? Side length is one-dimensional. This is still representing area. This is the ratio of the areas, okay? We need to find a side length. So we're not going to use 4 out of 9 to go into our proportion. Nope, because that would be a silly mistake. We are going to square root both of these. Then we're going to use this ratio to find a missing side length. This 8 is the smaller polygon, so I'm going to put it with the smaller number in the ratio. And lo and behold, we are going to cross multiply and divide. So that side XY is 12 centimeters. Okay, if you want to pause it and try this one on your own, I highly recommend that, and then come back and see how you did. All right, so finding XY. So XY is going to correspond with BC. So 15, and we don't know over here. We're going to use these areas. Okay, wow, great. Those correspond, but this is good to me? Nope, because I need to reduce it. So 135 divided by 15. Again, download this. The length is on Canvas. So that is 9. So please remember that is 9/1. Okay, when you need a fraction, you make that fraction. You can put any number over 1. Okay, so this is ratio of areas. We're looking for a side length. So again, that ratio is useful, but it's not exactly what we need. So we have to square root 9 and we have to square root 1. So this is the ratio of the side lengths, which we're going to use in the proportion. 15 is the larger side, so I'm going to put it in the numerator with the larger number. I don't know this side length. That's what I'm trying to find. Oh man, that was easy. So this side length is 5 inches. Hope y'all thought that was fun. I'll see you tomorrow.